Hey, this is Math 2, Unit 8, Worksheet number 4. Alright, we're going to express in simplest radical form. All variables represent positive numbers, so we're going to take these apart and break them down to the simplest radical form possible. So, what that means when we look at this first one here, 20 can be broken apart into 4 times 5. 4 can be broken apart into 2 and 2. Because it's a square root, not a cube root, I'm looking for some partners up. Right, some partners. So when I have a pairing there, 2 and a 2, that means I can take that number and put it on the outside of the radical. Okay, and if I have anything that's left by itself, like the 5 here, that stays inside the radical. In this case, that's all I need to do. I have a 2 root 5 square root of 5. That's my final answer there. Okay, when we look at number 2, for example, 63 is 9 times 7, so if you know your math facts a little bit, 9 can be broken apart into 3 times 3, and so because I have a little group, a little pair there, that means I can put 3 on the outside of the radical, and the 7 is going to stay inside because it doesn't have a friend. It's all by itself. Sorry, 7. That's how it works sometimes. Alright, we have the square root of 50, m cubed n, so let's break these all apart. 50 can be broken down into, I could do a 2 times 25, and 25 can be 5 and 5, so already I have a nice little partner there. M becomes m times m times m, so I have one partner there. That guy's left by himself, and I have the n by itself. So what can go on the outside of the radical? I can have a 5, I can have an m. Remember, when I make a partner, I only put one of them outside. It's a partner, but that just means because there's 2, they're squared, so I make it on the outside. Now on the inside, what's left still? I have a 2, I have an m, and I have an n. So I still have the radical 2m n right there. So for my answer, I have 5m, and then I have a square root of 2m n. Okay, so you can see how that works. That's a great example of just how that works out. Number 5, we're doing odd ones here from this point. I'm going to break apart 225, and that becomes actually, believe it or not, 15 times 15 is 225. I know, who knew? And then for k, we have k and a k, we have another k and another k and a k. How many? 5. 1, 2, 3, 4, 5. Looking for partners. So there's a partner, and there's a partner. Here's a little partnering. This guy is by itself. So on the outside, I can put a 15. I could put a k. I could put another k. On the inside of the radical, I still have 1k left. So these two k's can combine. K to the first times k to the first is actually k squared. And we have still the k on the inside there. All right. So that's how we get for number 5. Number 7. This is a cube root, so now I'm looking for 3 of a kind this time, not just the pairs, right? So let's break apart the 40. 40 can break apart into 4 and 10 if we like, and then 4 can become a 2 and a 2, and 10 can become a 2 and a 5. So right now I can see I have a little triplet right there. Perfect. For the D's, I can write them out as 1, 2, 3, 4, 5, 6, and there's 7 and 8. So there's 8 D's, so I have a triplet here, and a triplet here, and then 2 left over. So what goes on the outside of the radical? I have a 2, I get a D, I get another D. On the inside of the radical, I still have this 5, and a D, and another D. So rewriting that then, this becomes 2d squared, and the square root of 5d squared. Oops, I gotta make sure I do this here. This is cube root, right? Because that still stays the same. So it's still cube root of 5d squared. Okay, and that's it. So a little bit kind of jumbled numbers there, but that's kind of like this. 2d squared times cube root of 5d squared. Okay, number 9. Also looking for cube stuff, so looking for triplets again. So let's break apart my 216. Now, I'm not sure what 216 is, so I broke it apart into 2 times 108. I broke up 108 into 2 times 54. Broke that up into 2 times 27. Broke that up into 3 times 9, and that into 3 times 3. At that point, I recognize that I have a triplet of 2's, a triplet of 3's for my whole number. Okay? For the A's, a to the 9th, I have a, 2, 3, 4, 5, 6, 7, 8, 9. So I have 1 triplet, 2 triplets, 3 triplets. For the B to the 7th, I have 1, 2, 3, 4, 5, 6, 7. So 1 triplet, 2 triplet, and this guy is by himself. And C to the 5th is 1, 2, 3, 4, 5, 1 triplet with these guys by themselves. So on the outside of my radical, I have a 2 times a 3 times an A times an A times another A times a B times a B times a C. Those are on the outside of the radical, right? Or in other words, I have 6 a to the 3rd b squared c, and underneath my cube root here, that's still cube root, what's left on the inside is 1b and 2 c's, or c squared, and that's what's left on the inside. So I have 6a cubed b squared c, and then the cube root of bc squared. A little bit crazy, but it does work out that way. All right, number 11. Okay, let's first of all, I can't do anything with this as it is because I just can't multiply things together when they don't have the same, well, yeah. Well, let's leave it. So for first off, what I want to do is I'm going to go ahead and break this apart, square root of 8. I can take the square root of 8 and I can think about it as being, well, there's a couple ways of doing this. So sorry, I'm hesitating here because I'm thinking about which way I want to show you. On my notes I did one way, but I'm thinking of another way, so sorry about that. Now on my notes, what I did first of all is I broke this down into 4 times 2. And then the 4 becomes 2 and 2, which means I can put that on the outside of the radical because it has a partner. So I rewrote it as 3 root 5 times 2 times 4 is 8 root 2, right? Because I still have the 2 here left inside the radical. So I did some reducing first. That just helps speed up the process a little bit. At this point now, what I can do is I'm going to multiply the numbers on the outside of the radical together. 3 times 8 to get 24. And then in the radical itself, I still have 5 and 2, which make 5 times 2 is 10. The reason I hesitated there was because I could have done that initially. I could have said, well, 3 times 4 is 12, and then in here we have square root of 40. But by doing that, what I really end up doing is I still break this apart, and this becomes 4 times 10, and 4 is 2 and 2, so I put the 2 on the outside, and 12 times 2 is 24, and what's left on the inside? The 10 still. So you end up in the same spot. It's just a question of where you want to pull out, any squared numbers inside the radical there. Here I did it with the 8, here I multiplied and did it with the 40. So you get the same point, it's just up to you which kind of order you want to go in and what do you see first, all right? So just keep that in mind. There's not like a perfect order every time. Okay, moving down to number 13. For 13 here, we have square root of 4x times square root of 8x to the 3rd. So I'm going to break this apart here because it's just a little bit easier. I have a 2 and a 2 and an x, which means I can put that 2 on the outside. Okay. Now I still have an x on the inside here, so let's just keep it right there for now. Here I have a 4 and a 2 and a 2 and a 2, so I can put a 2 on the outside, and then I have an x and an x and an x. I have a cluster there, so I can put one of these x's on the outside. And so what I'll have left on the inside though is a 2 and an x. Okay, so I have so far, if I kind of break this apart, I have 2 square root of x times 2x square root of 2x. So now I'm going to multiply the outside part. 2 times 2x becomes 4x, okay, and I multiply the inside parts. I have 2x and another x, x, and 2. Well, here comes a partner up there, which means I need to push this to the outside. So that becomes 4 times x, square root of 2. And x times x is squared, so we have 4x squared root 2. All right, and that's kind of how that works. Again, you could put it all together at first if you wanted to. Be a little bit crazy, but you could. Right, we could say that this is 8 times 4 is 32, and this is x to the 4th power there, and that becomes square root. So if I just multiply together, I could do that. 32 becomes 16 and 2. Square root of 16 is what? What do you know square root of 16 is? 4 and 4. So I put a 4 on the outside. X to the 4th becomes 1, 2, 3, 4, cluster, cluster. So that's x squared. And what's left on the inside? Just a 2. So you get the same spot, maybe a little faster that way, maybe a little more clear that way. Again, just look at what do you see, how do you want to work that out there. Okay, for number 15, notice that, and so we have to be careful, it says plus. That's right, plus. When it's a plus, you have to think of this almost like a variable. Like if I had a plus a, that becomes 2a, right? This becomes root 3 plus root 3. It's like they have a 1 in front, a 1 in front. So root 3 plus root 3 is having 2 root 3's. That's what that means. Okay? Keep this in mind as we turn the page and look on the back side. So number 16. Here we have the same bases, root 5, or same radicals, root 5. It's like having a 1 in front. So 1 plus 6 is 7, and the root 5 stays the same. All right? This would be the equivalent of saying I had a plus 6a. That equals what? 7a. Okay? Number 17, we have root 7 and root 63. These don't have quite the same bases, do they? So I can't do anything quite yet, but let's see what happens with 63. 63 is 9 times 7, and 9 is 3 times 3. Hey, look at that. There's a partner. So I can rewrite this as 2 root 7, right? Bringing that whole thing down. This goes to 3 on the outside, and I still have a 7 on the inside. Now I have same radical, right? 7 and 7. So I just add. What is 2 plus 3? 2 plus 3 is 5. And the root 7 stays just like it is. Okay? I'll leave 18 there for you to do on your own. I'm going to look at number 19. Number 19, I don't have the same radicals, so let's break them apart and see what we can come up with. 72 is 9 times 8. That is 3 times 3. 8 is the same as 4 times 2, which is the same as 2 times 2 times 2. So I know for this one, I have a 3 that goes on the outside and a 2 that goes on the outside. So 3 times 2, well, I'll write it out here. 3 and a 2 on the outside. On the inside, I still have this 1, 2 left. Let's subtract that from the 50. The square root of 50. Square root of 50 is the same as 25 times 2. 25 is a 5 and a 5, so I can put that on the outside. So here's my 5 on the outside, and I still have a radical 2. And we're going to add that to a 7 radical 2. So now at this point, I have all the same radicals, 2, 2, and 2. So I can just add or subtract. Well, 3 times 2 is the same as 6. I'm just going to erase it real quick and turn that into a 6. 6 minus 5 is 1. 1 plus 7 is 8. And the radical 2 stays the same, so I have 8 root 2. Number 21. Our last one here, we have 5 minus 3 root 7 plus negative 7 plus 8 root 7. All right, so our whole numbers, 5 plus a minus 7, I can put together. 5 minus 7 is minus 2. Now I have the negative 3 root 7 plus 8 root 7. So negative 3 plus 8 is a positive 5. And the root 7 just stays a root 7. All right, so it's a little bit like combining like terms here in this case here. This would be the equivalent of saying I had 5 minus 3a plus negative 7 plus 8a, right? That's the idea here. And so you just rewrite stuff and say, I'm combining like terms. There's the 5 and the negative 8. gives me negative 2. A negative 3a and a positive 8a give me a positive 5. Right? Same idea. 23, moving down to the next section. Rationalize and simplify each expression. Okay, so what that means is we don't want to ever having a square root in the denominator. Okay, so to get rid of that, I'm going to multiply the top and the bottom by the square root that's in the denominator. So square root of 5 times square root of 5 is equal to simply 5. So radical 5 times radical 5 is equal to 5. On the top, this becomes 2 times the radical. Now, if you're wondering why, how, what, right? Remember, this is also 5 to the 1/2 times 5 to the 1/2. When the bases are the same, what do we do with the exponents? We add them. 1/2 plus 1/2 equals 2. So 5 over 2 is the same as 5 to the first power, which is why it's just simply going to be 5. So that's how that works out if you want to look at it as exponential way. Okay, number 25. For number 25, again, a couple ways of looking at this here. I could multiply top and bottom by root 15. That makes my bottom equal to 15. And up here, I end up with the square root of 20 times 15, which is kind of a big, crazy number. Okay, so let's do this here. Let's break this apart. 20, I know I have a 20, and I know I have a 15. 20 becomes 4 times 5. 15 becomes 5 times 3. 4 becomes 2 times 2. This is all that's underneath the radical here. So I have a pair there, and I have a pair here, and this is what's left. So what goes outside the radical? I have a 2. I have a 5. Inside the radical is still going to be a 3. Right? And on the outside of the radical, I'm sorry, on the denominator, I still have the 15. Right? 15. So this becomes 10 root 3 over 15, but I can reduce that just by regular reducing. 10 divided by 15 is the same as 2/3, and then the root 3 just stays there. I can reduce right here. 10 over 15 is 2/3. So that's what I get for number 25. I use a lot of space there for that just so I can make sure it wasn't too small to read. All right, number 27. Okay, here we go. Square root of all this stuff. Well, this becomes square root of 25 is 5. And on the bottom, I still have square root of 6. I'm going to rewrite that. Okay. Oops, make sure I'm off the page. Good. So now I can multiply both sides, top and bottom, sorry, by square root of 6. The denominator becomes simply 6, and the top becomes 5 root 6, because I can't do anything with that there at all. That's all it is. And our last one for the day, 29. I want to get the root 5 out the bottom, so I multiply top and bottom by root 5. So on the bottom I have 2 times, well, root 5 times root 5 is what? 5. That becomes 2 times 5. That's all there is to it. And on the top here, 14 times 5 is root 70. 5 times 14 is 70. So that becomes root 70 over 10. And that's all there is to that one. I can't break that down anymore. That's it for today. Have a great one, and we will see you next time.